water, sewer, storm, street, traffic signals, sidewalks, and any type of traffic safety that's needed to ensure that we have a healthy community. Today we are out on the street and we are installing what is called a chip seal. A chip seal is a combination of an asphalt emulsion, which is actually designed in a lab by chemists, and it helps as a tackifier or a binder to add rock to the surface. The rock is used to add structure to the street. Now the reason cities use this type of material is because it's about a third of the cost as it would be to repave the street. As an inspector, one of the things that are most important is assuring site preparation. Site preparation today will consist of assuring that all the natural elements have been cleaned off of the existing roadway surface. This includes dirt, which is performed by either blowing it out with an air compressor or using a broom, removing organics, which are weeds, and we can do this by either torching, so we burn them out, or we add a pre-emergent, which is like a weed killer, say a Roundup. But the pre-emergent actually helps keep the weeds from wanting to grow back. In addition to that, we perform what's called a crack sealing. So crack seal material is also an emulsion type material that's made out of rubber, and it has a binder which we apply into the cracks of the street to try to help seal those up. The reason that we want to do that and why it's so important to seal the roads is because the two major things that break down roads is sun and water. So when you have a road that's in good condition and you want it to last, by adding some type of a seal to it, you can help extend the life of the road. So today I'm going to go ahead and go over the application of installing an AR chip seal. As you can see, our surface has been prepped, and this is what we call alligatoring. The road is not in very good condition, but the compaction is still working well for us. The street structural section underneath the asphalt is in still good condition. So an AR chip, which stands for asphaltic rubber chip, is a great application for this. So we are at the stage of getting ready to apply the asphaltic emulsion. And as you can see, our street is nice and clean, and any of the major cracks have been filled with a crack seal. Now, this street right now is what we call alligator, and so the asphalt road is actually failing, and that's why it's cracking out. However, the street structural section, which is a mixture of rock underneath the street, is still in good condition, and that's why you don't see any potholing. So the first application is going to be the application of the binder or the asphaltic emulsion. So as an inspector, what I'm going to do is assure the application rate of the material. So the city taxpayers are paying for the contractor to come in and apply this material, so it's my job to assure that it's going down properly and that we're getting the amount of material that is in the contract. What this is it's a 3/8 cleaned aggregate, just a rock, and it is covered with asphalt. That asphalt helps keep down the dust, and it allows the rock to bind to the asphaltic emulsion. So right now this truck is applying the asphaltic emulsion, and as you can see, one of the things that I'll be making sure is in compliance is the spread rate. So what we want to make sure is that there's no holidays or voids that are happening in this at all. We want full, even coverage, which this looks great. To the emulsion binder while it's still hot. This should be coming out of the machine at about 375 degrees. I'm sure you guys can feel how hot it was. Down while the binder is still at least 325 degrees. Now because that chip is hot and because it has the asphalt around it, it's going to help bind to the asphaltic emulsion. And now here comes the pneumatic roller. within 90 seconds per the contract specs to begin rolling the rock in the binder. Ultimately, we're just trying to smash it in there to get it to stick. Now what we want to see is we want to see a little bit of that binder coming up through the rock, but not too much. If you have an abundance of the binder, then they're spraying too much at a time. And it will cause stickiness and tackiness, and ultimately it will stick on car tires and rip off the road. So what we're looking for is just a little bit of shininess coming through, so that way we know that the rock will be secured in the binder. So the asphalt on the chip helps keep the heat in it. If you were to touch this, it's very hot. This is the result of the application of the asphaltic chip immediately after it's done. And now you can see how that sealed the street compared to the condition that it was in before. And the cracking, which again is a result of the sun and water. And once the water can get down into those cracks, which at this point this whole entire street is subjected to water, it damages the subsection and ultimately causes deficiencies in the street and failure. One of the challenges that we have with infrastructure is natural environment, including minerals. In the city of Hillsburg, we have a ton of acidic dirt, and so anything that's directly buried into that dirt will be affected by the acid in it. For example, we have been installing copper pipe, and in the Uniform Plumbing Code, buildings still use copper pipe all the time. And if you put a copper pipe directly into an acidic dirt material, then what happens is you end up with corrosion. And as you can see, what's happened is over time, it's eaten the metal right off of this pipe, actually causing a hole in this. This is a typical water service. And so the public works guys have actually had to cut this out, and we keep it as an example to show how the acid dirt will cause damage to our water systems. So dealing with corrosion and acidic material, how do we use math or science to prevent it from happening? One of the ways that we do that is we've incorporated magnesium anodes. And what that does is it allows the acid in the dirt to eat and attack the magnesium instead of the metallic fittings on our systems. So I'm going to show you, this is a standard water meter service. This domestic service comes off of the city's water main and it feeds this building here. Now this is a standard water meter which will calculate how many gallons of water that they're using per month, and that's one of the ways that the city bills the customer. So in order to see if there is any cathodic protection, which is the installation of the magnesium bag on this system, I'm going to use what's called a voltmeter to check and see if there's any magnesium current on this service. So we will be testing this by using this machine, which will tell me if there's any current that's going from in the dirt and onto the machine. And what the magnesium bag does is it sits in water and it allows this current, and that's what draws the acid to the magnesium instead of our pipes. So I have this set up here, and the way that I would know if this was protected is I would have at least a -700 reading, and at this point I have a 0.007, which means that this line is not connected and it's actually subjected to corrosion. Ultimately, this will have to be replaced by the city within the next 2 to 5 years. Not only am I the public works inspector for the city, but I'm also the city's radiation safety officer. It's my job to assure that we're in compliance with the state radiation license and the DOT, which is the Department of Transportation, requirements when we're running what's called a nuclear gauge. So what this machine does is it sends gamma rays down into the ground, and it pops up data and determines how much void space
was in those rays, and that's how we determine max density. Now, max density is when you take a material and you completely take out any air space, so any voids or any moisture space. And the whole idea is, if I could take, let's say for example, asphalt, and I can compress it down as much as possible without any air or without any water, what would be the max density? And I use those determination to come up with calculations on how much compaction do we really have. So typical street section through the Caltrans specifications would be a 95% compaction on asphalt, meaning that when the contractor installs it and they roll it, they have to compact it to at least 95%. Okay, so that's a 12-inch water main, and that helps feed the city with domestic and fire water services. And so what we're doing today is actually lowering this main so then that way we can install sewer laterals. The difference between a water main and sewer lines is that sewer is gravity fed. Water main is pressurized, so it doesn't matter if the water main goes up and down. But with the gravity feed, you have to have positive fall in order for the system to work. So if you come over here, you can see that they've got the new water main bolted up and ready to go. We've added plastic on top of the metallic fittings to help prevent the corrosion that we were talking about earlier.